A transformation is a change in position, shape, or size of a figure. We use the term image to speak of the shape after it has been transformed. We use the term pre-image to talk about the original shape. And we use the word isometry to talk about the original figure and its image if they are congruent. Orientation is a term that we use to speak of the way it is turned. So if it has the same orientation, the two shapes have the same orientation, that means that they are turned the same way. We use the word reflection to mean a flip or a mirror image. We say that it's an isometry with reverse orientation. We use the word translation to mean a slide. It is an isometry with no change in orientation. We use rotation to mean a turn. It is an isometry, meaning it's congruent. However, it does change its orientation. And we use the word dilation to mean a change in size. So it can be an enlargement or a reduction and still be a dilation. And last, we use the term glide reflection to mean a translation that reflects. Let me remind you about the coordinate system. In the coordinate system, you have the x-axis and the y-axis. Where the two meet is called the origin, and that's the ordered pair 0, 0. This is quadrant 1. And in quadrant 1, our ordered pairs are both positive. Our x value and our y value is both positive. So an ordered pair like 2, 3 would be located in quadrant 1. This is quadrant 2. The x is negative and the y is positive. An ordered pair like negative 3, 4 would be in quadrant 2. In quadrant 3, our x is negative, our y is negative. An ordered pair like negative 1, negative 2 would be located here in quadrant 3. In quadrant 4, we have our x value positive and our y value negative. So an ordered pair like 3, negative 2 would be in quadrant 4. Now, we are going to do some coordinate geometry in that we're going to plot a pre-image and we are going to find the image. And we're going to work through the transformations that I talked to you about. We'll do a translation, a rotation, a reflection, a glide reflection, and a dilation. The one that most students have trouble with is the rotation. The others are pretty easy for students to understand. So let's start out with coordinate S, -1, -1, D, which is 3, 2, and U, which is 2, -6. So the first thing we will do is a translation. And a translation is done by giving typically a vector direction. The vector is written like this, with the first number telling you how the x value will change. And the second number will tell you how the y value will change. So if I give you a vector of 3, -2, this means that for all x values you will add 3, and for all y values you will subtract 2. Now when you're teaching students about translation, it often is helpful for you to set up a table where you list the x values and the y values for each ordered pair. So for point S, I have -1, -1, and for D, I have 3, 2, and for U, I have 2, -6. Now, the translated ordered pairs I can let be S prime. And for all the x values, I'm going to add 3. So to get the x value for x prime, I would have -1 plus 3, which is 2. And for d prime, I would have 3 plus 3, which is 6. And for u prime, I would have 2 plus 3, which is 5. For the y value, I'm going to subtract 2. So I have -1 minus 2, which is -3, 2 minus 2, which is 0, and -6 minus 2, which is -8. So the ordered pairs now for S prime would be 2, -3. For D prime would be 6, 0. And then for U prime would be 5, -8. So now I'm going to get graph paper and with a straight edge I'm going to make my coordinate system. going to plot the ordered pair -1, -1, which is S, 3, 2, which is D, and 2, -6, which is U. And so now I'm going to okay, so that's the original pre-image. Now to get the image, I'm going to use a different color pen, and I will plot two, -3, and that is S prime, 6, 0, which is D prime, and 5, -8, and that will be U prime. So I connect with a straight edge, and we have our transformation. Now, once your students get more used to how the vector affects the ordered pairs, if you give them the vector 3, -2, or I'm sure that you probably can do this as well, I can look at the ordered pair S, and I can know that this will take 3 to the right, and this will take 2 down for that point S. So if I go 1, 2, 3 to the right, and 2 down, I've located S prime. For D, I go 3 to the right and 2 down, and I've located D prime. And then U, I go 3 to the right and 2 down, and I have U prime. Now notice that it has the same orientation, meaning they're turned the same, and it is an isometry because they are congruent, and that is the conditions of a transformation. A transformation can go right or left, up or down, and that's why we use the slang word for a transformation to be a slide. Okay, now when we do our rotation, we're going to need our compass and our straight edge. And again, this is the one that students typically have most trouble with. It's harder for us to explain, I think, and it's harder for them to grasp. If you bring in a pinwheel and let them look at the pedals on that pinwheel, and as you blow this one to this position, then you have a rotation. And so if you go the other direction, you can take this pedal 1 over to here, and that is a rotation. So depending on how you are turning the shape, whether it will go in a clockwise direction or whether it goes in a counterclockwise direction. And so that will be one thing that we will need to know when we are given our directions on rotating an object. Another thing we will need to know, other than the direction, is the degree that you will be turning the object. Will you turn it 30 degrees, 40 degrees, 50 degrees? Will you do a half turn with it? If you go 180 degrees and this is your object, then your object now is down here like this. So it does a half turn. If you go 360, it's a full turn. So it's back to where it started. If you go 90 degrees, it's a quarter turn. Alright, so let's begin looking at what we're going to do with the rotation. Again, we need graph paper. We're going to make a coordinate system. And we're going to start out with just a point first. Let's look at a point T with the ordered pair 3, 4. And let's say that I want to rotate this counterclockwise. And I want to go 100 degrees. So not only am I going to need my compass, but I'm going to need my protractor as well. So find your protractor. First thing I want to do is to take my compass I want to make a radius from the origin to point T. And I'll make a circle. I'm interested in, since I'm going counterclockwise, I'm interested in the circle that is to the left of the point, but I can go ahead and make the full circle if you'd like. I'm also going to make a radius from the origin to that point T. So this was the radius of my compass, and now I'm going to draw that radius in. So point T, when it is rotated, will be somewhere on that circle. Since I'm going in this direction, I'm going to put the center of the compass on the vertex, on the origin, right here. That's the center. I'm going to line up the 0 on the segment that we made, and I'll count 0, 10, 20, 30, all around to 90 to 100. I'm going to connect that point to the origin. Now, where the segment from the origin to where I marked 100 degrees, where that intersects the circle I made, will position T prime. Now, it may not be always on an exact even ordered pair. I mean, it might be 1 1/2, 4 1/2, or it might be 1 3/4, 5 3/4. So it doesn't have to be whole numbers. Now, it looks like on mine that it pretty much did 1, 2, 3, 4, 5 up 2. So it looks like -5, 2 would be the position for T prime. But it doesn't always have to be an even number, or a whole number, I should say, or an integer. Doesn't always have to be an integer ordered pair. It could be a rational number ordered pair. So you could have fractions, but the point will be on the circle that we first made from T to the origin. Now, if you had a triangle, you would do this 3 times. You would do this with all 3 ordered pairs. All right, let's talk about a reflection. Which is a flip. Now, it's congruent to the original shape, but it has reverse orientation. So let's make a coordinate system. And let's plot the ordered pair 1, 1, 4, 1, and 3, 3. Okay, the easy ones are, let's reflect this about the x-axis. So I'm going to imagine folding this on the x-axis and mapping the points to where they would go in quadrant 4. So if I fold on the x-axis, this point is going to map here. This point will map here. And this point will map here. And so now I have a reflection of the original shape. Now if I want to reflect about the y-axis, then I fold on the y-axis and I imagine where this shape is going to go. Now for students that are beginning to learn about this, they need to actually fold. So if you fold that on the y-axis, this is where that shape is now going to be in quadrant 2. And so we know that this point goes here. This point goes here. And this point would go here. And then when we connect those, we have the reflection across the y-axis. Now sometimes we have other lines that we reflect. Like we could say reflecting around the line y equals x. Well, the line y equals x goes right through here. It would actually be a side of that triangle. And if I'm going to reflect about that line y equals x, let me draw that with the straight edge because that should have been on that side of that triangle. So if I want to reflect about this line, then I'm going to fold it on that line. And then I need to look to see where these points are going to go. Well, if these two ordered pairs are on the line, they're not going to go anywhere. But this point is going to come up here. And so when I fold on the line y equals x, I can see through my paper that that point will be right there. And now, what if we would want to reflect about the line y equals 2? So I find the line y equals 2, which would be here, and I fold on that line, and I look to see what would happen. If I fold on that line, this bottom part is going to come up, and the top part is going to come down. And so if I fold on that line y equals 2, notice what happens. The bottom part is up here now, and the top part is down here. And so it kind of flips it upside down, where this point would now be here, this point would be here, this point would be here. And so it kind of is here. So on a reflection, we will look at what happens to the ordered pairs if we fold on the line that we are reflecting about. So what will you need to know on a reflection? You will need to know what line you are reflecting about. Now I want us to look at what happens to the ordered pairs when we're reflecting about the x-axis. The x values are going to stay the same, and the y values are going to be opposites. So notice that the x value 3 is the same, but the y value is an opposite. The x value 4 is the same, but the y value is an opposite. So we can say if we are reflecting about the x-axis, if your pre-image is xy, then your reflected or your image will be x negative y. Okay, let's look at what happens to the x values if we're reflecting about the y-axis. If you reflect about the y-axis, our x value is negative 4, 1 for this point. It is negative 3, 3 for this point, and it is negative 1, 1 for this point. So in reflecting about the y-axis, your pre-image is xy, and your image would be negative xy. Now if we put two words together, a glide reflection, if I have the ordered pair 1, 2, and I want you to do a glide reflection, to glide we need a vector. So I want it to go 2, 1. So that means that it's going right 2 and up 1. The reflection has to be about some line. So we are going to glide to 1 and reflect about y equals, or let's reflect about the y-axis. So this is our new point. We're going to fold on the y-axis, and the point now is located here. So a glide means you're going to translate. Reflect means you're going to flip it about a line. And so we did a vector translation of 2, 1, right 2, up 1, and then we reflected it about the y-axis, which put it here. So we are at 1, 2, 3, 1, 2, 3. So we're at the ordered pair negative 3, 3. Alright, here is your assignment. I want you to translate triangle PUN with vertices P is the ordered pair 1, 0, U is the ordered pair 4, 6, and N is the ordered pair -5, 8. I want you to translate under the vector 2, 3. I want you to do a rotation for triangle ABC, where A has the ordered pair 1, 2, B has the ordered pair 4, 5, and C has the ordered pair 3, 3. I want you to go counterclockwise (70 degrees). I want you to reflect triangle TEX, where T has the ordered pairs 5, 2, E has the ordered pair 1, 3, and X has the ordered pair 2, 1. And I would like for you to reflect that about the x-axis.